Saishriya Satya.
Welcome to Agora Math Circle.
Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel. This is Junior Advanced, and we're going to be learning about exponents. So, what is exponents? Well, exponents basically explain how many times n is multiplied by itself. An example of this is n to the power of 4, which means that n is multiplied by itself 4 times. So n to the power of 4 is equal to n times n times n times n, 4 times. Now here's an example of an exponent. 5 to the power of 2. In this case, 5 is the base and 2 is the exponent. 5 is raised to the second power, so 2 is the power. So, and you can say this as 5 to the power of 2 or 5 to the second power. Now let's do a practice problem together. Write the following in exponential form. The first one is 23 to the third power. And as we know, 5 to the power of 2 means that 5 is the base and 2 is the exponent. So 23 to the third power means that 23 is going to be the base. So 23 will be like that. To the third power, which means it's raised to the third power. And 3 is the exponent. So it looked like this. Let's do the other one. 2 to the power of 4, meaning that 2 would be the base, as we know from the example above, and the power or exponent is 4. So 2 to the power of 4 is written like this. So now let's learn about squares. So when the exponent in an expression is 2, instead of saying to the power of 2, we can also say squared. So here's an example of this. Since the exponent in this case is 2, we can say 5 squared. Remember, before saying squared, you'll also have to include the base. And in this case, the base is 5, so we have to say 5 squared. Here are some squares that you should know. And when it is to the power of 2, when a number is to the power of 2, like this, or squared, you are basically multiplying the base to itself 2 times, since the exponent is 2. So, here are some examples of squares. So let's look at an example like 5 squared. In 5 squared, what we're basically doing is multiplying 5 to itself 2 times since the power is 2. So since we're multiplying 5 to itself 2 times, that's 5 times 5. And 5 times 5 is 25. So that's how you get the answer. And this goes as well for all the other numbers. So in the previous lesson, we learned that when the exponent is 2 in an expression, we can just use the term squared. Now, the same applies to the power of 3, which is cubed. So when an exponent in an expression is 3, instead of saying to the power of 3 or the third power, we can just say cubed, which means to the power of 3. And when we are cubing a number, or when the expression is cubed, the base, in this case, 2, is multiplied to itself 3 times. So that would be 2 times 2 times 2. Now, these are some cubes that you should remember. Let's take an example of these and try to solve it. So, what about 4 cubed? So, 4 cubed, as I said, we're multiplying 4 to itself 3 times. So, that's 4 times 4 times 4. So, what's 4 times 4? 16. And 16 times 4 is 64. So, 4 cubed is 64. And that applies to all of these. Now let's learn about square roots. This might be complicated, but don't worry, I'll explain afterwards. So let's first read about what square roots are. Square rooting is when you find a number in which, when it's squared or multiplied 2 times, it produces the number at the start or inside the lines. And when I mean inside the lines, I just mean the number inside this bracket here. So let's go ahead and use what we know from the explanation to find the square root of 4. So we have to find a number in which when it's squared, and we know that when a number is squared, it's basically multiplied 2 times. So we have to find a number in which when it's multiplied to itself, it produces 4. Now let's go back to the lessons we learned before, and let's think. Well, we know that 2 squared is 2 times 2. And 2 times 2 is 4. And does this follow our criteria that we need? Well, it needs to be squared or multiplied 2 times. And it needs to produce the number inside the lines. And 4 is the number inside the lines. So that means the square root of 4 is 2. Now, why don't we go ahead and try another problem? Why don't we go ahead and try the square root of 16? So let me just fill this in here. So, we have to follow this same thing. We have to find a number in which one it's squared and only squared, so it's multiplied to itself. It has to equal 16. Now again, let's go back to our charts. So we know 1 squared, 2 squared, and 2 squared, 3 squared, and 4 squared. Now let's look at 4 squared. Well, we know that 4 squared is basically 4 times 4. And let's see whether 4 times 4 is equal to 16. Let's look at 4 times 4. So that's 4, 8, 12, 16. So 4 squared does equal to 16. So the square root of 16 is going to be equal to 4. And let's make sure that this follows the criteria. Again, so it needs to be multiplied to itself 2 times, or squared, which we have done. And it needs to produce the number inside the lines, or what was at the start. And it does produce. So we know that the square root of 16 is 4. So now that you know what square root is, or you have an idea of what square root is, and I just want to say, if you guys do not understand, make sure to rewind the video and look at this lesson. So that's basically how you solve square roots.
Okay, let's learn about simplifying square roots and cube roots. So the square root of a perfect square is obviously going to be a whole number, but we have to simplify numbers that are not perfect squares a little different. Let's do some examples together to solve how. So the square root of 27 is obviously not going to be a whole number, so we have to simplify further. First, let's write down the factors of 27. That's going to be 1, 3, 9, and 27. Now, which of these are numbers that are squares, are perfect squares? Well, 9 is a perfect square, and 9 times 3 is 27. So we can split 27 into 9 times 3. Now we can bring the 9 out, since the square root of 9 is 3. So that's 3, and we keep the square root over there for the remaining 3. So this goes out, and we leave this back in. So the square root of 27 is going to be 3 root 3. Now let's solve for the cube root of 128. Once again, the cube root of 128 cannot be a whole number, so we have to split further on. First, let's try splitting by 2. Now, 128 divided by 2 is 64. Is 64 a perfect square? Yes, it is. So we can split 128 into 64 times 2. Now, what is the cube root of 64? 4 times 4 times 4 is equal to 64. So the cube root of 64 is 4. So we can bring this out. So 4, and we leave the 3 right here. So it's 4 cube root of 2. So the cube root of 128 is going to be 4 cube root of 2. Now let's go ahead and look at the properties of exponents. There's going to be 7 properties of exponents, so make sure to pay attention. Let's start with the first one, which is the product of powers. That's when there are 2 exponents and you're going to be multiplying them. So this can only work if the base is the same for both of the exponents, in which case this is. So if it's a to the power of n times a to the power of m, what you need to do is keep the base the same and add the 2 powers, or the 2 exponents. So let's look at an example here. 3 to the power of 2 times 3 to the power of 3. We keep the base the same, but we add the 2 powers. We get 2 plus 3 is 5, so it's 3 to the power of 5. Now, let me give you an example. Why don't you guys go ahead and do 4 to the power of 2 times 4 to the power of 4. Now let's go ahead and do the power of a power. This is basically when you have an exponent and
you're multiplying that to another power. So it's a to the power of m to the power of n. So when you have a problem like this, what you need to do is keep the base the same still and just multiply the two powers. So let's go ahead and look at an example of this. So that's 2 to the power of 3 to the power of 2. So we keep the base the same and we just multiply the two powers. And you get 2 to the power of 3 times 2. And we get 2 to the power of 6. Now let me give you an example problem for this. Why don't you guys go ahead and do 3 to the power of 2 to the power of 4. Now let's go ahead and do the power of a product. And this is when there's two bases that are being multiplied together and they have one power. So when that happens, you need to separate the bases and you need to distribute them the power. So in this case, we have a times b to the power of n. So what you need to do is you need to separate the bases, but you need to add the power in. So it's a to the power of n, and you have to multiply, times b to the power of n. We're basically sort of using distributive property here. So let's look at an example. 4 times 3 to the power of 3. So we keep the bases the same, and we just add the power in. So we get 4 to the power of 3 times 3 to the power of 3. Now let me give you an example. Why don't you guys do 6 times 2 to the power of 2. Now let's go ahead and look at a negative exponent. So that's a to the power of negative m. So when that happens, you need to turn this exponent into a fraction. And the top always, the numerator always has to be 1. So it's 1 over, the base stays the same, a to the power of, and the exponent is now going to be positive. So it's 1 to the power of a, 1 by a to the power of positive n. So let's go ahead and look at an example. 5 to the power of negative 2. So we change this into a fraction in which the numerator is 1. And since we've changed it into a fraction, we can now turn this exponent into a positive number. So that's 1 to the power of 5 positive squared. So that's 1 over 25. Now let me give you an example. Why don't you do 4 power of negative 4? Or maybe I should change that up because it might be a little difficult. Maybe I should do 4 to the power of negative 2. Okay, so now let's go ahead and do 0 exponent. Now this is pretty simple. With any number that has a power of 0 or 0 as the exponent, the product is always, the solution is always 1. So I could keep going on. 1,000,000 to the power of 0 is still 1. So in this case, we have 5 to the power of 0, and it's 1. Now let me give you an example. Why don't you guys do 60 to the power of 0? And we all know that the solution, in this case I'm going to solve, is going to be 1. Now let's go ahead and do the quotient of powers. So in the quotient of powers, it's basically when an exponent is divided by another exponent. So we're basically doing the opposite of what we did over here. Since we're dividing, we're going to keep the base the same, and we're going to subtract the two powers. So I actually wrote this down wrong, but what we're actually going to do is a to the power of m minus m. So let's look at an example here. So it's 4 to the power of 8 by 4 to the power of 5. So we keep the base the same and we subtract. We get 8 minus 5, which is 4 to the power of 3. Let me give you an example. Why don't you do 5 to the power of 3 by 5 to the power of 2. Now let's move on to the last property of exponents, which is the power of a quotient. This is when a number is being divided, the base is being divided by another base, and it's to the power of something. So it's a divided by b to the power of m. So we're going to do the same thing we did at the power of the product. We're just going to separate the bases, and we're going to add in the exponent, and we're going to keep how it is the same. So if it's division, we're going to keep it as division, and if it's multiplication, we're going to keep it as multiplication. So it's a to the power of m, because we're separating them, divided by b to the power of m. And I'd like to include that a can't be 0 in the negative exponents. And in 0 exponents, a can't be 0 because 0 to the 0 doesn't make sense. And a to the power of 0, well, actually 0 to the power of a negative number also doesn't make sense. So, and in this case, that's the same thing. B can't be 0 because anything divided by 0, as we already know, is undefined. So that's why it can't be 0. So we do AM divided by B. So let's try this out here. 3 by 5 to the power of 2. So we separate them. We get 3 to the power of 2 by 9 by 5 squared. So that's basically how you do this. And I just simplified, you don't need to. So these are basically the properties of exponents. Okay, let's do some practice problems based on what we've learned of exponents. The diameter of Mars is about 81 kilometers. This is not a true statement, I just did it for the purpose of this problem. Write the diameter in base 3. So we're trying to solve for 81 in base 3, meaning that 3 is the base, and we're trying to solve for the exponent. Let's count to see. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So that's 4 times. So 81 is equal to 3 to the power of 4. Now let's do the other one. Find the least positive whole number with which 72 should be multiplied by to have a product of a perfect square. Well, we're trying to solve for what 72 should be multiplied by to have a perfect square. Well, what numbers can we multiply by? We have to solve for the least positive number. So let's start from all the way from the least. And 72 times 1 is just 72, and that's not a perfect square. So we have to do 72 times 2. Now 72 times 2 is 144. Is 144 a perfect square? Well, if you know your squares, then yes it is. 12 to the power of 2 is 144. So our answer is 2.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!